Okay, so Val increases the potential energy using her slingshot, so increasing the potential energy of this bearing. And so basically we can say the potential energy, or the energy of position, is equal to the average force multiplied by the distance that force moved it into position. And so the average force in this case, we're told, is 100 newtons. And as she pulls back, the elastic is resisting her pull. And so she needs 100 newtons in order to get it moved back, an average of 100 newtons. And then next, we are looking at 30 centimeters. And so we want to convert or move that into meters. And so we could say that's 0.30 meters. And multiply those together, and we end up with 30 joules. And again, let's talk about what this is relative to, because potential energy is always relative to something. So this ball bearing, relative to the front of the slingshot, it was moved 30 centimeters back from there. And so if we were to say the change in potential energy, it's the potential energy final in that position where she has it all the way pulled back, minus its potential energy initial from where it was loose, where the elastics were loose, to where she pulled it back. And so that change in potential energy by pulling it back was our 30 joules. And so potential energy, we just want to keep on thinking that it's always relative to something. And that will help us out when we see more complicated problems later.